one.
Mm.
I'm not really used to indices, so I'm gonna do this.
Sure. You may want to zoom in a little bit before you screenshot. You may want to just nice. Okay, you screenshot what you want. You tell me.
It's actually it's quite hard to see, but you understand it's simplify 16
No, then zoom in. Then zoom in more. Then zoom in more. That will solve the problem. Don't know what connection problem. Zoom in a bit more. You should be able to do it. There you go. There, much better. Right. Okay. Yeah, if you're confused with that, I do want to talk about it. That's good. That's good. Right. Okay, give me 3 or 4 more.
Yeah.
Okay, this will be accurate drawing, but I already give you the access, so it should be easy. But if you want to put this, go ahead. Go ahead.
No, it's
This
not
is
only
a big
that,
mark.
there's also stuff behind.
Yeah, which you need to draw the graph first. So put in the graph. You do need to draw the graph. Put it for me so I can help you with it. Basically, put in everything. This is a big mark question in exam. Let's get it right lah. Your type, your diligence can do what? Okay. Now let's put everything. Easy to hard. The last questions are usually hard.
Okay, so last
Good.
question 20.
Well, up to you. If you want to talk about this, yeah, sure. Also very this one is a kind of a semi-open open-ended question lah. Right, that thing. Also big marks in exam.
Huh?
Yeah. This question, the open-ended question. this question. The questions you're asking are good. Anything else?
Let's see. Okay, ah,
Good question. Good question. Give it to me. Standard form, you have problem, also give it to me. That one, give it, yeah. Yeah. Good question. Big marks. 3 or 4 marks. 4 marks, 4 marks. This is 4 marks.
that's all.
Good. The standard form, you no problem? Just checking.
Huh?
Standard form, number 6. Any problem or not?
What's in the form?
Number 6 lah.
Oh, we're not doing that yet. As in, like,
We are
it's
not?
not homework.
We are not? Oh. Huh? You mean you might do this later? Something like that?
No, as in, it's not homework. Only the circle ones are homework.
Oh. Oh, sure. All right. Okay, again, the question you asked are good. So which one first?
I'll just do this one first.
Sure, let's do that. Help me zoom out a little bit, then I can follow you better. Do you have any idea how to start 5?
Wait, I mean zoom out.
Yeah, nice, very nice. Do you have any idea how to start?
No.
Okay, I'll give you the first big clue. This clue almost always works in EMAT, not in AMAT. In EMAT, this is just very likely gonna work.
Yeah.
Wait, sorry, I'm typing. I gotta release the type first. There you go. This is just the thing to work in EMAT. It will work.
Make base the same. Is it?
Do you understand what I'm saying?
No.
Okay. Let me explain. Because this is very important. This is the strategy you need anyway. Very simple. Once you know this, everything's gonna be fine in EMAT. Oh, sorry. Let me. Okay, I believe I can write. Okay, good. Now, the base means something like this. 2 power x. This guy is the base number. This guy is the in this order power, right? So here you have base, which is 36, and base, which is 216. Their base is not the same. Okay, make them the same. This has base of 9, this has base of 27. They are not the same. Make them the same. The smaller, the better. Meaning to say, don't restrict yourself to 36 or 216. It can be a smaller number. 9 and 27, it can actually be a smaller number. If you request next hint, the number will be my hint. What number should you aim for?
1.5.
Now, am I making any sense? 1.5 might not be a very good base, I think.
No. This one is 36. 1.5.
Right. If you can deal with 1.5, I am totally fine. I'm very surprised that you can figure out 1.5. I am very surprised.
I just guess.
If 36.1, have you confirmed using calculator?
Yeah.
If you have confirmed, then I'm totally fine with you. You're quite unique, but you are correct, and that will work. Go ahead. Now the base is the same. If you still don't know what use is that, tell me lah.
Let me see. I mean,
another thing you're good at, Nicholas, you just simply try and check. That's another thing good about you.
yeah, 36 1.5 is important. So x plus y is 1.5. But how do I know? How like what if it's a bigger number and like a more like a weirder decimal?
Right. So not to be ambitious with 1.5. I mean, having said that, I'm quite proud that you simply guess and check, that's something that students don't usually do. I'm very proud. Now you're saying that what if you guess and check and you cannot find, correct? That's what you're
Yeah,
saying? Very simple. Don't do 36, do 6. Do you understand?
yeah.
6 and 6. Now I want you to try that just for experience. Both should be 6. Try please. It's still guess and check.
Like put 6 and then the what?
Both become 6. Both become 6.
So as in 36 becomes 6 and 216 becomes 6.
Yeah, I mean, that's the guess lah. We still have to find out what it is. So please try. I mean, try to find out what it is.
So it'll be 6. X plus y equals 6.
No, no, no. Okay, let me show you. Let me show you. Again, if this is new, I do want to teach you this, right? This is useful for both EMath and AMath. Again, I did say that this is strategy for EMath, but it is needed in EMath. 6 power 2 x plus y. Make sense?
Yeah.
Equals to 6 power 3. Please check with calculator correct or not my guess.
Oh, that's what you mean by turning
Yeah,
everything into 6.
yeah. 6, which is the smaller, the better. Doesn't mean your 36 is wrong. Again, I'm quite impressed. But you do, I mean, have more experience lah, have more flexibility, right? Now you do whatever you want. You deserve your 36, you deserve your power 6, whatever, right? You do what you want. You're quite good.
Wait. And what? How are you supposed to do after this?
When the base is the same, we have a very big advantage, okay? You're going to do 36, okay? I'm going to do powers, I'm going to do 6, okay? So we have a comparison, understand? You do 36, yeah? Okay, I do 6. Now, look, I'll just make sure that the base is like that. So this is going to be 2x plus 2y. Does this make any sense?
Yeah.
If the base is the same, then the power is the same. There you go. Happy, happy.
Oh, then x plus y equal. Ah, yeah.
Right. Now,
That
your
makes-
case, you do 36. You do 36.
I think your 1/6 it works more well. If I refer back to this worksheet, I feel like doing that will help me.
Okay, but I want you to do 36 on Jamboard. Be
Okay.
proud of what you did. Be proud. Do it first. Then you're free to do whatever you want after you do 36.
I literally just guessed. So
Guess and check. What you did is guess and check. You're good. Guess and check. Okay? You're
that's
good.
how I guess.
That's good.
That's how I check.
I mean, you check using calculator, ma. That's good lah. That's good. You're not afraid of guessing and you go and check. So good for you. Remember, make base the same. I need to see the left-hand side. Good. Yeah, good. Left side base 36. Right-hand side base 36. That's the idea.
Uh oh wait. You mean like this?
I mean, do as I do. Do as I do. Let me see the final. Okay. Try your best. Try your best. I don't help you too much first. I want you to think.
Uh so 216 into 36.
36. Yeah, I know 216, but change it to 36 power 1.5, right? Okay. Now, when you achieve this, what can you do? If the base is the same, then the power must be the same. Okay. Now, your result is just the same as mine, correct or not? It's just the same.
Yeah.
Okay. So then you do whatever you want.
Yup. What? I like it. Someone use it.
Then do what you feel better. Of course, you should do that, but know your options lah.
Two x plus what? 2x. Two x plus 2y. 2x plus 2y. So that'll be nah. And how do I do the second one?
Nicholas, no idea, man. Same thing, same principle. Make the base the same, the smaller the better. Okay, let me clarify the principle. Okay, let me clarify the principle. Gotta guess the base. Gotta guess and check lah. So look at the left-hand side. The base is currently 9. Look at the right-hand side. The base is currently 27. Right? Just focus on the base. The rest doesn't matter too much. Now you gotta choose a number for the base. Are you going to choose 27, 9, or something smaller?
3.
All right, then choose 3 and convert everything to 3. That's called make base the same, right? Make the base to be the same. Okay, good. Tell me, 9 is 3 power
Wait.
what? Hey, come on. Hey, amateur mistake.
There we go. Hmm. I don't. What do I do now?
The base is the same, right? Okay, which is just happy. Now, pile all the power up. Pile everything up. So the square root, you gotta pile it up. You gotta put it up. Up. Represent the root with power, right? Represent root 3 with power. You know, you gotta pile everything up to the power side. Do you understand what I'm saying? Okay, that the 2y is fine, but the square root, you gotta handle it also, right? Also, later lah, maybe next step, sure thing.
Wait. Huh?
What you're doing is fine. What you're doing is fine, but look, on the left-hand side, get rid of the surd. Make the surd into power. That's the left-hand side.
Wait to make it half, so 2 half.
Yeah, 2 times half, and then combine them, right? And then combine them into like one big chunk of power.
Yeah, it's gonna be half, but 2 there, so it's gonna be 1. So it's gonna be 3y.
Good. So then put y, which is nice, right? Nobody's gonna complain. The same thing with the right-hand side. Combine your 3x with power 4/3. Combine them.
Well, 3 and 3, so it's gonna be 4x.
Now, look at this situation. This is our goal. This is where things becomes easy. This. Look at that. Don't you think this is where, all your hard work is paying off?
Yeah,
All right, then make it pay off. What's the payoff here?
I do like.
Yeah, you do like. So again, base the same. Therefore, what? If base is the same, therefore the power must be
It's the same. So y
the
is
same.
equal to 4x.
Correct. That's your payoff. You should like it lah. You should like it.
And then I can do some weird thing by doing.
With the first one and the second one, in this case, gonna be quite doable for you.
Wait, I can do this, right? And I do some
You
like.
look. What you're doing is not wrong. Okay, look. What you're doing is not wrong, and I agree with you. But I want you to see an easier way. You can, in this case, substitute the y with 4x. Probably
Oh wait, yeah, yeah, yeah,
easier.
yeah, 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 yeah.
Probably. Okay. You should aim for the best way to solve. I mean, a nice way to solve. Huh? Right? Not so bad. So yeah. Remember, what you're doing is not wrong. It's just that, get used to nicer stuff lah.
1.5/5.
Do something nice. Mami, apa aja, Mak? Apa aja yang jadi? Find your Y, Nicholas, and then confirm.
Wait, it's okay to write a decimal in a fraction.
This is EMAP, so I mean, decimals are allowed, but for confirmation, yeah, you want exact. Want exact. Keep it fraction. I mean, decimals are the habits of EMAT lah, but maintain some of your AMAT habit lo, so
No,
fraction
because
lah.
this is 1.5/5. So it's
Which is 0.3, which is 0.3. It's not that hard. It's 0.3.
what?
It's 0.3 what?
0.3.
Uh-huh.
Wait, yeah. What? Oh,
Hello, hello.
oh yeah.
What's
Yeah,
going
yeah.
on? Okay, 0.3. Come on.
Let me
Okay.
just
Go.
okay.
Yeah, and then go find your Y lah. Go find your Y. Then I want confirmation, please.
So it'll be There.
This is final
It's equal to
answer, but I
0.3.
want confirmation. I want confirmation, please. How do you
Okay.
confirm? How do you ascertain your marks?
I just do this part again.
No, the original. Never confirm from your working. Original. 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 The
Okay.
question is out.
So y is 1.2. So that is 3.73719. Yeah. Then is
Wait, do not confirm from your working. Confirm from your
I'm doing this
original
part.
question. Oh, I'm so sorry. I cannot see your calculator. Go ahead.
Oh,
Okay, type properly.
3.73719. Yeah, okay, yeah, it's correct.
Good, good, good. Now you're supposed to confirm with the first one also, the first equation. Do that. That's much easier. 36 power something. Very easy.
Wait, no, yeah, it's correct. Because 0.3 plus 1.2 is going to be 1.5.
Correct. Correct. Good, 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 good. Now, put a sign of quality, the C circle. Your teacher, you don't know, but I know what that means. That's a sign of quality from you. Quality work.
A C.
Quality work, brother. Okay. When your answer is confirmed by yourself, you do that. Okay.
Okay, I'll try it.
A small one will do. So that you know that you did this before. You did a confirmation. You don't need answer key. You don't need me to tell you that you're right. You don't. You know that you're correct. You're not dependent on me or the answer key.
C. Okay.
Remember this technique, it will give you many, many marks.
Yeah. Okay. Well, can I put one more question? Like a question if you have time.
Okay, fine.
This one.
That's fair. Looks complicated. That's fair. Go ahead.
Oh,
Then I'll prefer to replace this, replace the first question lah. Your first question you will do yourself. Okay?
okay.
Okay, choose your question.
Okay, it's in 5.
I know. Which question do you want to do now?
How about both?
Oh, sure, sure, sure. Okay. Now, what do you want? Do you want me to show you my method? Do you want me to try first?
Yes, I want to show you my method.
My method, I'll give you two methods. Whichever is confusing, just forget about it lah. Okay.
Yeah.
First method is separate. Okay. That's the first method. Then you just press the calculator lah. This is just calculator. This is also just calculator. This was calculator, and you'll get the answer. I'll write down for you. You gotta figure out the answer yourself if you like this method. The other method is, well, whatever feels easier first. That's what usually people do. Nothing wrong with it, I suppose. So which one feels easier first, Nicholas? Now I'm asking you lah. 27
Well, I feel like
x
the
power 4.
first arrow is a method on like how to make it not look complicated.
You like the first method, really? You like
No,
the
no,
first
no.
method?
I'm just saying it looks like a method to make it not look complicated, but like I think this doing whatever feels easier first is better.
Well, the first technique, let me just tell you, works better the harder the question. The second technique, of course, when the question is easy, it feels easy, and when the question is hard, it feels harder lah. It's a totally different feel one.
Mm.
Now you know your own school standard, and you know yourself. Which one do you want me to help you practice? The one that is easier when things are hard, or the whatever feels easier first lah?
How about whatever feels easier first?
Okay, then I ask you lah. So which one is easier first? You have a lot of options like 27 lah, or x power 4 lah, or 64,
27.
or y power 12. Yeah, I mean you got a few items inside ma, so you just deal with whatever feels easier first lah.
So
You
I
use which one? Which one do you want to deal with first again?
I'll just do this, right? I'll just do this.
You can do that, yeah, you can do that, and I'll write down for you. So you just press that, equal, and then that's 1 over 9, right? So on the top, it becomes 1 over 9. Okay, then what else do you want to do?
X4, so just be 4.
Okay, so 4 times, right? So what that be? Minus 8 over 3, right? I mean, what else can it be like? Hey, come on. What are you doing?
Yeah, minus 8 over 3, yeah. And 64.
What are you doing? 64, right? 64 power minus 2 over 3. So what is it?
Oh. Oh my. Okay, so you cannot do that.
Come on, it's 1 over
116.
16. Come on. Yeah, thank you. Yeah, okay, thank you. That's the 64. And then the y over 12, y power 12 will be
Negative 24 over 3. Negative.
yeah, which is negative 8, right? It's negative 8. Correct?
Yeah.
So you do that separately, that's fine. And then now time to simplify more lah, because he wants positive. He wants positive. There you go.
So just
He
switch it
wants
around.
positive. Yeah, you just go drop here, go up there lah, right? So I'll do 16 over 9. That's that's the number side. And then I'll do y power 8 and then over x power 8 over 3. And then you should be done there. Happy. Everybody happy. Okay.
Yeah.
Whatever feels easier first is a fine method. That's fine. As long as you do it correctly, nobody complains. Now, I'm going to erase it, okay, Ken? This one I'm going to erase. I want you to just be confident doing it yourself, right? You have enough skills. You have enough skills.
Six times negative 2 over 3 is just negative 4. Right? Why negative A over 3? Teacher?
I cannot read the typo. What is that? X power. What is X power? Is that X power 4?
No, it's x power 6.
That's the problem. I thought it's 4.
So it's
That's the
not. Yeah,
problem.
it's wrong.
Yeah. Okay, yeah.
So I was so confused. Like, yeah, it's negative 4. Negative. Negative 4. And it's 64. So 64 power negative 2 over 3. 116. Y negative 24 over 3. Eight.
Good.
Eh?
Eh.
I was some reason there was a negative. Yeah, that's right.
Yeah. Okay, then you just finish it up lah, right?
And switch it around. Switch it around.
Okay, and you gotta deal with the 1 over 16 and I stop switching the 1 over 16. What are you talking about?
I keep doing this. Oh,
Weird stuff.
yeah, that's fine. And then just in case. Oh no, can't. So I don't know. How do I convert that 1 over 9 something?
In exam, you just press the calculator law, 1 over 9 divided by 1 over 16. That's just the safest way. Sometimes that's just what you do. Sometimes. I'm not saying that that's the best way, but that's
10444.
definitely a smart way. I don't want decimal, please. Fraction, please.
Does this look
Fraction.
same?
Oh, your typing got problem. Okay, your typing got problem. Okay, AC, your typing got problem. Okay, let me show you what it means. Okay, why don't you try this? 1 over 9 divided by 1 over 16, but use the division sign.
Okay.
That might clarify things up. Okay, there's a danger in the way. This is the correct answer. That means you type wrongly just now in that sense. It doesn't look wrong, but it's wrong.
So it's 16 over 9.
Now you are Nicholas. So do you want to know why, or can you just rely on calculator? That's up to you.
Honestly, I don't know how the multiple layer fraction works on calculator. It's so weird. So
Then I'll tell you the easier way to type. Now press the fraction button.
fraction.
Fraction button. Below option. Fraction button. The box over box. Okay. Then if you are in doubt, if you don't know how it works, then let's be safe. Just on top type 1 divided by 9. Also works, man. Then at the bottom, or do 1 divided by 16. You kind of just make yourself safe lah. Either way, it's fine.
Oh wait, it works like this, all right? Like that.
Yeah. That's what you should do. Yeah, but the problem with this is that you cannot
It's really
check
hard.
after you type. Yeah, it's not nice. It's not good. You cannot figure out whether you're right or wrong. That's why it's not good.
Yeah.
Right. Okay. Better be safe, man. If you rely on calculator, then let's not let the calculator mess with us, lah. Right.
Yeah.
Anyway, you got your answer. So could you try doing B yourself first?
Oh, okay. Sure. Yeah. Now, Teacher,
Yeah.
I need just like a reminder. When it's like this, right? Teacher,
Yes, yes, I can hear you. Yes.
it'll be short like this, right?
That one is correct. Yes, that one's correct. Definitely. And you should do that. Yes. Yes.
Right.
That should help.
I'm gonna put this X slightly lower.
You're doing looks fine. Hi, 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 hi. Isn't that a division sign?
I put it, huh? Oh, wait. Uh,
So divide 1 over. Is that what you're saying? Just checking. Is that what you did? You changed the division into times 1 over. Just
yeah.
checking. Okay, that's fine. Good. I don't mind that at all. Totally like it. Now, what do you do after this? This is fine. This is a good setup.
Well, it's just uh the X is the same, so I just put X underneath. Is half times 17 over 4, right?
Times.
Yeah.
Half times 17 over 4. Come on. Come on. No, no, no.
Huh?
Come on. No, no, no.
Plus,
No, no, no. Yeah. Plus. Not time. Come
yeah,
on.
because it's not a bracket. It's just like a times XX, not bracket. Like the yeah.
At this point, we don't need to explain, but know that it's not times lah. Know that it's plus.
I'm just I'm just gonna put in mixed number improv. Im, I forget the name of the fractions. I forget what improper and mixed number is again. Uh, my nose is so blocked. Um,
Um, does it help if you clear it first? I mean, it's not nice. It's not. It doesn't feel nice.
no, it has been here for a day, and I can't even clear it. If I try to
Uh,
clear it, no, there is so
mhm.
much buildup mucus in my nose that like it becomes solid. When I try to take it out,
But
right, it's like
uh-huh.
it's
But if you don't clear it,
it's
it's worse. What? No, me?
it's unlimited. I try to clear it. I clear it every single time, but like it feels like it's unlimited.
Does that mean that there is a source of allergy in your house or something like that? Or is it the rain?
It just happened today, so it can't be so valid.
Oh. Not your
Anywho,
bunk bed? I mean, no?
uh, it happened with. I mean, it can't be why, but I is there such thing as a wood allergy?
Of course, of course. Or whatever is living in the wood. Your bunk bed is wood. Your bunk bed is wood,
Yeah,
not metal. Oh. Frankly speaking, you gotta be open to that possibility. It's not that you cannot have a bunk bed, but you gotta find out whether the wood is causing you this. It is possible, what? Okay? Keep an open mind. Keep an open mind. You don't want this to happen every day.
it can't be a good wood allergy. If it's a wood allergy, I'll sneeze every single time I'm near a wooden tree. A tree, not a wooden tree.
No, no, no. Because the wood in your bunk bed is already processed. You might be allergic to the chemical in the wood. You might be allergic to the sawdust. Real trees don't have chemicals and sawdust. You might be allergic to the glue that they are using in your bunk bed. They have all those sorts of things.
Oh yeah, huh?
Okay. You
Those
you cannot compare it with a real tree. You cannot. Right? So just be open, and I think for allergy you gotta find out what. Okay. If not, then you suffer, ma.
okay. I think I got it. 9x 1 over 3 x 19 over 4. Or like, do I have to leave it in mixed number, like 19 over, not 19 over 4, like, do I have to, like, wait,
How did you,
huh?
oh yeah, it is 19 over 4. No, no, you still have to combine the top x and the bottom x. You still have to do that.
Huh?
Yes, you still, because you can. Remember?
Oh, yeah,
In
huh?
my method separating, that means every x you combine, every y you combine, every number you combine. So
So,
you
like,
gotta combine
can I
the
just get rid
x.
of, can I, like, cancel? I can cancel it from here. Wait,
I mean, if you know how to cancel, I mean, that's the test here. Do you know how
can I
to?
just cancel from here? Like, cancel this part and, like, this part.
Yeah, but how do you cancel 1/3 in half? Do you know? I mean, it's not directly cancelable. How
Uh,
do you cancel it?
oh my.
Yeah, go ahead, go ahead. Clear it up. It's just better, okay? It's just better. Yeah, here. Yeah. Hey, Nicholas, when there are no students, I'm okay. You know, my wife also experienced allergy. That's why I understand. Hey, when there are other people, you protect your dignity. Mute it first. Understand?
Yeah, okay.
When you're with me, I'm okay. I'm okay. But when you're with other students, mute first. Okay? But don't hold it. It's not nice. Just do. Yeah.
Much better. Okay, so
Good. Do you know how to? Oh, never mind, never mind. I gotta give you the clue here. I gotta give you the clue, okay? Now, whatever you do in exam, okay, let's say in exam you really want this mark, okay? And you're just not certain. There is something that you can do. You can use your calculator. You can rely on it to find out what is right and what is wrong. Now, please choose a number to replace x for now.
3.
Okay, so let's say you have 3. I'm going to ignore the 9, okay? The 9 is just there sitting nicely, okay? 3 power 1 over 3, am I correct?
Yeah.
And then over 3, 19 over 4, am I correct?
Yeah.
Okay, now you are going to make some guesses. Again, the 9 just stay there quietly and nicely, just ignore the 9. You're going to make a guess. If you combine them, what is the power? Meaning to say, there are only very few options, you know. It's either plus, minus, times, divide, correct or not? Is 1 over 3 plus or minus or times or divide 19 over 4. Those
Minus.
are your options. Okay, then you do a minus and then you just test using calculator. If you're right, then you're right.
It's a divide,
Good to
so
know
it
in exam.
should be minus.
Minus, but test it out. Make yourself happy in exam.
Okay.
Go. Test using calculator. Then you're happy.
I will do the thing first. Oh. 313, That's 0. Oh, let me.
Fraction,
0.0078111. Okay.
Okay,
And
okay,
then
sure.
the next one. 0.0078. Yeah, that's correct.
Yeah, nice. Okay, good. So now you know that what you're doing is correct. Never mind what you memorized, right? Sometimes our memory fails us in exam. Who cares? Let's get them up.
But like, technically, can I cancel this part? Like, cancel this x with this?
Please
like,
don't.
X is...
Please don't. Please don't. Please don't do magical things. You already know the right thing. Please don't. I'm serious.
Okay.
I cannot even explain why canceling doesn't work, okay? I cannot even explain that. But it does not work.
One over 3 minus 9. 1 over 3 minus 19 over 4. That is 9x negative 3 over 12. Oh, that's convenient. That's gonna be on the bottom. So it's gonna be, wait, so this is gonna be 9x minus, oh, what's up here? Minus 53 over 12, which means it's gonna go on the bottom.
Yeah, I think it's fine.
So be,
I mean, the numbers are not nice, The numbers are not nice. But what can we do, right? Okay, in exam, you do not like this ugly number, correct or not? This is something not comforting at all. You gotta comfort your heart. It's a matter of your heart, So assign a random number to X and then confirm with the original question, confirm with your final answer. That will give you peace of mind, right? Spend some time. You're fast enough to spend time, right?
I'll do 3 again. Can't go wrong.
3 is fine. 3 is fine. That's great.
That is a very 0.070
Not nice number.
265.
Yes.
Yeah. And I'll confirm the 3. Yeah. 3
Yeah.
times 9 over uh, uh, 3. Yeah, I forgot. Divide by, oh, no. Uh, 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 yeah. I have to change this 3 to a 4. 3, 17. There's a 0.0703002. Yeah, completely correct.
So your ugly number answer is totally correct. Totally. In exam, I mean, quite happy lah, quite happy lah.
Oh,
Yeah.
my correction tape does not want to work.
Yeah, your correction tape is not very cooperative.
Ah,
It's weird. It's weird.
I've genuinely gotten angry at my correction tape before.
Maybe you should change or something. Should you?
This is my fourth correction tape.
Huh. I'm
I'm
not
not
sure.
even
I haven't been
joking.
using it for a long time.
No, I changed it like a few days ago.
Right.
There we go. Wait, can I have a break? I tired.
Good. 5 minutes. Right.
Okay.
Yeah. Pakai bantuan enggak? Cuci ya. Pakai bantuan enggak? Pakai ya. Tapi sebenarnya itu saya senang. Sebenarnya udah bisa bisa juga tahu sendiri. Oh, nggak usah pintar, nggak usah pintar. Karena dalamnya kan dia yang dalam apa saya? Iya, mau sama. Kita tahu.
Teacher.
Sorry, I muted. Yes, Nicholas?
Sorry, I had like a sun, so I sleep. Anyways, I'm back. So let's continue.
Sorry, I'm muted when we're talking about. Sorry. We're a bit slow. So you only have one question left. You got to choose. Which one? Page 6 or page 7? You can only do one. Even that might
Okay,
not
which do you
finish.
think is harder?
The problem with the problem with wait. The problem with the page 6 one is the harder one is at the back. So you do the front one first, and then on Wednesday we talk about the hard one if you cannot. Make sense?
Yeah.
Okay, that's for page 6. Now for page 7, this is let's try that. Let's try question 7. You gotta read a lot for page 7.
Sandy
Question 10.
plans to buy a car. She needs to work out how much money she will need to pay for the car and its maintenance. She finds the information below to help her work out her expenses. Bleh. Sorry,
Before we continue, yeah. At this point, whatever you read, if you don't understand, you gotta ask me. Clear?
she needs to work
Okay.
out how much money she will need to pay for the car. No, I understand.
Then the table. The table is very important.
But I didn't say it. Yeah, but doesn't it go on?
Yo, Nick, the table, Nick. We don't have
Down
much time.
payment 40,000. Monthly installment $690 per month for 7 years based on a loan amount of 50K. Insurance 10,000. I mean what? $1,015 per year. And car servicing recommended after every 10,000 kilometers. 270 per servicing. Total distance driven by Sandy in 2020, 16,823 kilometers. Average petrol consumption of new cars is 8.2 liters per 100 kilometers.
Okay.
Uh,
Now, before you continue, the last part is also the hardest part. Now look at part B first. How many marks is that?
6. Oh my.
6 or 7, yeah, which is normal. The harder part of B is that it is always an estimate. There is no right one answer, and then you got to justify something. You got to estimate, you got to justify. That's the hard part. Part A1 and A2 is so easy. It's just graph reading. All the information that you read just now is actually for part B, not for part A. Okay. Now you try part A first,
Okay.
just to warm up.
And
Okay, just to
estimate
warm
how
up,
much
and
1
then
liter
we'll go.
of petrol cost in December 2020. It is April 2020 and March 2021, December 2020. So it's over here. So it's gonna be here. 2.1 is here. So 2.12, 2.14. I was right. 2.1. 2.12, 2.14, 2.1. Then I'll just December is this part, right? Yeah, December is this part. December 20. Then I just 2.12. 2.12. The greatest percentage increase in petrol prices between 2 consecutive months. That is definitely going to be January to February.
You do that?
Is it just
What is
minusing?
the answer?
Like minus over?
Wait, sorry, because I cannot see your work. Have you estimated part one? Sorry.
Yeah.
Oh, you're done. Okay, I'm sorry, you're done. Okay, you're done. Good, good. Okay. So then I am very confused. Why is 2.12? I'm very confused right now. Why is it 2.12? Why is your
Because
answer 2.12?
1
December is
liter.
not even 2.1. No? It's not even 2.1, Hello. You're very this is very
I mean,
confusing.
oh my, 2.0.
Hello,
I don't know
hello.
what's single one.
Yes. Thank you very much. 0.02. Okay, be careful. Almost lost that 1 mark. Right now, the part 2 lah, the greatest percentage increase in petrol price. No. Look, a little bit of, again, this question is the fancy one lah. Are you going to calculate every month to find out, or are you going to use some sort of a shortcut to find out?
I
See,
can
what's the
definitely tell
greatest
which one is the
percentage
highest increase.
Ah, good. Then just whack that. That is using the graph. That is what it means by the phrase using the graph. You don't just read everything. You just, yeah, must be this guy lah. Then you just whack. No? So whack January and February lah.
Is it just that?
Jan and
Plus,
Feb, come on, Jan and Feb.
wait, how do I do it again?
Whack the Jan
I don't.
first. Whack the Jan first. Whack the Jan and then whack the Feb and then you think.
Okay. The Jan is 2.08 and the Feb is 2.32.
Okay. So you got those two and then now you think. Percentage increase. Come on.
Is it
How many marks is that again? Wait, how many marks is that?
3?
Word it lah. You think lah. Come on, you think. Come on, man. Not complicated.
Oh,
Just
no.
think.
I kind of forgot. Oh, no.
I want you to think.
Um, is it minus like 2.32 minus 2.08?
Over. It's a percentage, right? A percentage usually means there's a fraction on top over at the bottom. What over what, right?
2 point. Oh yeah, it's a 2.32 minus 2.08 over 2.08 times 100.
Percent. I will agree with that. Either we are both right or both wrong. This one cannot confirm lah.
Wait, 2.32 minus 2.08 over 2.08 times 100 times 100 is 11.538461. Okay.
Looks about right to me.
Estimate. Wait, do I just like do the 3 SF?
Oh no, percent is oh yeah, percent is 3 percent is 3.
What is that?
Okay.
Yeah.
Now, the hard part is part below. Part B is we have to use, well, almost all the information at the part. Now, you cannot start anything without even understanding what is paying a car and doing maintenance. You gotta understand that first, and I'm gonna help you understand that until we end lah. Only when you understand, then we can do something. Now, let me ask you, do you understand what it means in this case to buy a car?
Yes.
Then tell me in your own words. No need fancy things. Just tell me what is Sandy doing when she is, I think she, right? Yeah, she is buying a car.
Like You have to like pay out in monthly installments. If you cannot pay the whole thing, you have to pay in monthly installments with increasing interest.
Okay. Let's start from basic first. Let's start from basic. What is the price of the car? You tell me.
40,000 actually. Yeah.
You are wrong. The price of the car is not 40,000. You're wrong already. They don't explain, you see. They don't explain. That's the problem. They don't explain.
The price of the car
They just
is
yeah.
40,000
40,000.
plus 690.
How do I know? That's not.
It's not for oh yeah, it's not. It's 690 per month for 7 years. Is it?
Technically, no. 690 per month for 7 years is technically more than 50,000. Would you please calculate first? What is 690 per month for 7 years? Please try.
It's 50,000.
Okay.
$57,960. It's more. Yeah, it's more.
Yeah, so it's not 50,000, it's more than 50,000. Am I correct?
Yeah.
How much is it? Just tell me.
It's more. It's 57,960.
All right. Then does it make sense when the question say based on a loan amount of 50,000? Does that make any sense? This is 57,000 something. The loan is 50,000. Is this making any sense, or the 50,000 is trying to fool you, or what's going on here? What is going on here?
I don't understand.
All right. Now listen to me carefully. Technically, if you have 90,000, you pay 90,000 for the car. The down payment is 40,000. Sandy took a loan for 50,000, meaning she needed 50,000 plus 40,000 to buy the car. So if you have 90,000, you pay 90,000. The car is only 90,000. How do I know? Again, the down payment 40,000, that's part of the car. The loan is 50,000. So when Sandy go to the bank, not to the car company, right? Go to the bank, he asks for the bank, hey, loan me 50,000. And he take that 50,000 from the bank, give it to the car company plus 40,000 of her own money. So the car is 90,000. Make sense so far?
Car is 90,000.
Yeah, because 40 plus 50.
Yeah.
Sandy does not have 90,000. Sandy only have 40,000. Only have 40,000. She go to the bank, which is not the car company. Bank loan me 50,000. Now, obviously, the bank will ask Sandy to pay back 50,000 plus interest. Of course not. Make sense or not?
Yeah.
So the bank will finally ask Sandy to pay back in 7 years 57,000 blah blah blah.
Yeah, because the
That should make
interest.
sense. Correct. So the car was 90,000, but Sandy end up paying more than 90,000 because she has to take a loan. I hope that makes sense.
Yeah.
Now, read the question one more time. Estimate an amount. No right or wrong. Sandy will have to pay for her car, including its maintenance, blah, blah, blah. So, first thing first, is it going to be 90,000 or 97,000, blah, blah, blah?
97,000.
I agree. Then, plus what? Plus insurance, plus car servicing.
Wait,
If you
pay
think
for the
must
car
plus petrol
must
also,
include those as well.
you read the question one more time. You got to read the question now. Estimate an amount of Sandy you have to pay for the car, including.
Oh yeah, include yeah. Okay.
Right. So it's like the total thing, not just
Okay, let
the
me.
car price.
I'll split it up a little bit to make it easier. I'll do the
Sure.
like actual car payment first, and I like the loan first.
Can. You probably should do that.
Oh,
Okay, Nicholas, at this point, I gotta attend to the other student, yeah? So you do first, and then if there is anything confusing, then I will talk to you on Wednesday. Would that be okay, Nicholas?
Yeah.
Yeah, yeah. But we did talk about the hardest part, I believe, lah. So now it's up to
Over
you.
7 years. So it's 10,000. Oh, I'm really almost done. Car servicing, recommend after the doctor service. Wait, must it also require the patrol? The patrol?
You think? I'm serious. You gotta think. That is your decision, not
I
mine.
mean, does it? It only says maintenance and her car. Oh, patrol.
You gotta decide. I'm serious, Nicholas. The reason why this question is whatever your answer is, you gotta justify. That's all. So if you include the petrol, you justify. If you don't include the petrol, you justify. It's that simple. It is not a right and wrong, but whatever you put, you justify. Justify any decisions that you make. See? You
I have to
understand what I'm
say,
saying?
like, I have to say, like, I don't put
I
patrol because
include the petrol, or you don't put the petrol because, or you put the petrol because, something like that.
I don't put patrol because it's not maintenance
Because,
nor part of the car, nor part of the payment.
sure, then you say that lah. Then you say that. Okay. Or you put the petrol because blah, 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 blah. You just have to just.
Then also,
This is the kind of question.
all distance driven by
Okay, Keston, I can see you, yeah? Keston, I can see you. Can you hear me?
Yeah,
Okay, Keston. Any updates, Lee?
no.
Any holiday homework?
For metal,
Okay. Do you want to discuss your holiday homework? At
How
least
am I
the hard
supposed to
questions?
do car
Okay.
servicing?
Okay. All right. Then please put them in the hard question and let us.
If she's driven, teacher. Oh no.
Okay,
Okay.
Nick. Never mind. Wednesday, okay? Wednesday. Gotta
Okay.
stop. Okay. You can stay, but we gotta stop discussing for
Okay. Wednesday.
Wednesday. Right. For the graph one, same thing lah. Do until the end. The end is the hardest one. Then we talk lah. And then you should be a very happy person. Okay.
I put one question inside.
Please tell me. I've already read it. Now, oh, this is memorized. I know. Now, what is your question? Tell me. As in, why are you concerned with this one?
What does the surgical instrument have to do with steel?
Wonderful. All right. Wait. You want to understand or you just want a short answer? I can give you any.
Understand?
All right. Then I'm going to just share my screen just for you can just ignore it. And then I'm going to show you something. Now, obviously, even if you have been into a surgical room, I have, right? maybe you have also, you will probably not see the instrument yourself. What? I mean, do you want to see the surgeon cut a knife into you awake? No, right? You what, right? Okay. But, well, here is a surgical instrument or a surgical knife, right? Which you won't see directly, I hope. It's a bit scary. So here's what it looks like. Okay, don't know where this is from. This is from India and whatever. What is extremely sharp? Okay. Now, to be fair, is it better for a surgical knife to be made out of, well, steel or I guess aluminum? Maybe that's another option.
Steel.
Steel, because any idea, chemistry-wise, you should be able to answer this. Why steel, not aluminum?
Because the alloy means harder.
Okay, you like hard things for knife. Why hard things for knife? Steel chemistry.
So that doesn't break.
Actually, okay. Answer it in the most practical way first. It is true that it doesn't break, but aluminum also doesn't break. Aluminum also don't break. But aluminum is soft. Steel is hard, or rather harder. If something is harder, easier to be sharper, if that makes sense.
Yeah.
If you are soft, you can lose to the thing you're trying to cut. So you're soft, you lose. When you lose, you don't cut. So now back to the answer. So everything is steel, which is that's great law. All that is left is to decide, do I want high carbon, low carbon, mild, or stainless? This is also steel chemistry. Do you have anything to eliminate first?
Stainless.
You're going to eliminate stainless. I am going to show you the picture first. I'm so sorry, I got. Now, for whatever reason, surgical knife is not use and throw. It's not. I'm not sure why. I'm guessing it's a very high quality knife. So rather than using once and then throw, they will sterilize it basically, all right, and then use again, right? Now look at this steel cutting into somebody's stomach. Are you sure you do not want stainless steel? Are you sure?
But does stainless steel have anything to do with like hygiene other than not rusting?
So think about it carefully. Again, chemistry or biology, I suppose. Would you want the steel to rust, I guess, for a surgical instrument?
No.
Would you want your kitchen knife? Your mom have a kitchen knife using it. Would you want your kitchen knife to rust?
No.
Biologically, because rust can harbor certain bad bacteria. So you don't want that to enter your body. And this is kitchen knife accidentally cut you. That's bad. Surgical knife will actually intentionally cut you. So really rust will be very bad. If that makes sense, stainless steel probably shouldn't be eliminated. It probably should be an option, if that makes some sense.
Then if stainless steel isn't one of the options, what's the answer?
Okay. It is, I believe it is one of the option, yeah. You cannot eliminate it. Sorry. When just now I asked you which one to eliminate. You did
Oh,
say eliminate stainless steel, right? Correct. Correct or not? I did ask you.
I heard wrong.
Oh no, you thought that stainless steel is the answer. I'm sorry. You
Yeah.
thought that stainless steel is the answer. Oh no, then I agree with you. Now asking you elimination. No, I agree with you. Like it should be stainless steel. Put it another way, you should eliminate mild steel and low carbon because being mild and being low carbon has no advantage on sharpness at all. At least high carbon steel can be very sharp. But then again, I don't want to just be sharp. I need to be sharp and I mean, this is a little bit less sharp, a bit less. Because stainless steel is slightly less hard than high carbon, but definitely plus very good hygiene, which I agree with your answer. Okay.
Hmm.
Whether it is memorization or logic, you decide. I think it's both. Do you have another question?
Finding.
Okay. Okay, I see your next question. Let me confirm that you have learned blast furnace, Keston.
Yeah.
Okay. Okay. If you have learned it and you know the 5 reactions, you can answer this question. Do you know the 5 reactions?
No.
All right. I'll review to you, then I'll show you. Basically, I want to show you how to memorize them for exam. Okay, this is one way to memorize them. You do need to memorize them. They will never tell you. They expect you to know. Okay, so might as well run through them, how to memorize. If that benefits you, good for you. Okay, it'll take very little time. So first, there are 5. 1, 2, 3 together, 4 and 5 for purity. 1, 2, 3. Now, the raw material for a blast furnace is very logical one. You will put in coal or coke, and then you will put in iron. Correct or not? No, wrong. You will expect iron to go out. That's the purpose of blast furnace, to get iron, which is to say, at the end of reaction 3, you should see Fe lah, because that is what you expect blast furnace to give you. It will be in liquid form because it's melted. Make sense or not?
Can you put any compound of iron inside?
Not compound. I guess they don't call it compound. They call it my ore lah, I guess. Now, what chemistry-wise, you need to know what is iron ore. Now, that's the chemistry part. As for common knowledge, it's, I suppose, more like a common knowledge. You mine iron ore and then you process it to get iron, if that makes some sense. That's more like a common knowledge kind of.
Yeah.
So chemistry tells you what is iron ore. What is it?
Iron oxide.
Yeah, I mean, it's MCQ, so let me see. Okay, they call it hematite, English name, iron 2 oxide or iron 3 oxide, don't know lah. But you will memorize this for O-level syllabus, Fe2O3, which kind of tells you that this is Fe3, not Fe2 lah, I suppose. If that makes sense.
Yeah.
It's Fe3. Fe2. So does that mean that A is wrong? Maybe, maybe not. Who cares? We are reviewing the reaction for now. So you got to put in iron ore, got to put in coal, and you also got to put in air. Kind of those 3, I was hoping that it makes sense, not memorized. Now to you, is it sense? Is it memorized? Is it both? What?
Makes sense.
All right. Then where do I put the iron ore? Reaction 1, reaction 2, or reaction 3? You think?
1.
No, 3. Surprisingly, or not so surprisingly. I mean, in the end, you want Fe on the right-hand side, you got to have some Fe on the left-hand side. Simply put, this is the reaction that you're aiming for. This is it lah. How to convert iron ore to iron. Reaction 3 kind of makes a lot of sense. That is what you want. Okay, so far so good?
Yeah.
Now, what you need to memorize a little bit is the fact that you gotta use CO. And then this will become CO2. Actually, it is a simple reaction. Look at number 3. The most important essential reaction is rather simple. You just have to answer the question, why CO? If you know that based on chemistry, very easy already. Balance it later lah. This is not balanced. Does reaction 3 make some sort of sense?
Yeah.
Now, it's not balanced, you balance it later. I don't recommend you memorizing the balance. I mean, you are quite a smart student. I think it's better for you to balance it yourself rather than memorizing. If you have extra capacity to memorize, that's totally up to you. Now, I hope it makes sense that the purpose of reaction 1 and 2 is to make CO. Why CO? According to chemistry, CO is extremely reactive. Extremely reactive. Why is that good? Then CO can steal the oxygen and become CO2. We don't care about CO2. This is a waste. This is what I want. How do you know that CO is reactive? Chemistry or biology?
Maybe because like it's a catalyst.
No, it's not catalyst. No, it's not. CO cannot be a catalyst. CO is No, CO, never mind, I won't explain. But you must understand that I asked you to make CO2 before, remember? It's the C double bond O thingy, right?
Yeah.
Now, if I ask to make CO, it will appear extremely weird. There is almost no way to make CO that can satisfy the forehand of C. I mean, how can it be? C has 4 hands, O has 2 ends. Then you go CO. Where are the 2 hands going? Right? Correct or not?
Yeah.
If you think about it that way. So keeping it simple, CO is extremely reactive. So a few things as an example, because first of all, she's very unhappy. Think of this CO2 as happy lah. Happy by itself, not happy for us. We don't like CO2. But CO is even worse. This is a very unhappy thing. In biology, you will learn that CO poisons people. Why? By stealing the hemoglobin's ability to bond with oxygen. Am I making any sense right now?
Yes.
CO can do that because CO is so unhappy, so reactive lah. It'll bond to anything. In this case, it'll bond to our hemoglobin, making our blood useless for oxygen. It's really bad. Okay. Another thing that we use CO for is in the catalytic converter. Have you learned catalytic converter?
Yeah.
So in catalytic converter, you see CO plus NO. Okay.
Yeah.
Become CO2 plus N2. Both are relatively harmless here, relatively harmless. And this one is very bad. This is bad. And this is rather bad. So catalytic converter kind of converts CO and NO into 2 harmless things. So in chemistry, you learn 3 usage of CO, only 3. Or rather 2 lah, 2. Using CO to make it more harmless, CO plus NO, that's one use. Second use in blast furnace. Third is not used. Third is how to avoid being poisoned by CO, which is to say you shouldn't lock yourself in a car in a garage, something like that. So you kind of learn. CO is reactive. That's all I want you to remember. And therefore, CO, it can be used to steal the oxygen. Ta-da! This is the reaction. Any question on reaction number 3?
No.
Please balance it first so that we don't leave anything behind. I don't think the oxygen balance. Try again. You stop tell me. Huh?
So just this.
Check. Right. Now, I see how you do. I would like to show you the best way to balance something. Obviously, not for this reaction. You can memorize this reaction, but for other reactions, you need to balance. I think the way you balance is the worst way possible, but let me explain what it means, okay? Let me explain what it means. Okay, that's why it takes a lot of time to complete. Now, you start with these two. You start with this guy and this guy. This is very bad because of the oxygen side of things. The oxygen side of thing is bad because on the left-hand side, you have this and this as oxygen. You have two things with oxygen. That makes balancing these two extremely difficult. Doesn't matter the carbon. The carbon is easy. The oxygen makes it difficult. This guy makes it difficult. That is the worst start, so to speak. Because we cannot guarantee anything. Worst start. What is a good start? A good start is very simple. I choose two things. This and this, for example. I'm so sorry. Not that. Oh, okay, never mind. I criticize you too much, right? Okay, so all I can say here is this, right? If you choose C and C, if you C and C, I mean, put it this way, you're right in what you do. It's either 1, 1 or 2, 2 or 3, 3. Keeping it this way is X and X. It's just that the problem is I do not know whether it's 1 or 2 or 3. Something like that, if that makes some sense.
Yeah.
Okay. However, choosing the other guy doesn't seem to give you a lot of benefit. If I choose this and that, I still have the same problem, which is oxygen, right? Hey, I have oxygen here and I have oxygen here. I have one benefit though. This guy doesn't have oxygen. See? No oxygen at all. Correct enough.
Mhm.
With this, my 2 is guaranteed. I am guaranteed to have 1 here and 2 here because I have no oxygen here. So far so good, yeah?
Yeah.
Now, this helps a lot. Once you fix 1 and 2, figuring this is 1, 1, 2, 2, or 3, 3 becomes so much easier. So this is a worse start, but let's not start with that. Just do it as a second step, keeping it simple. Now, once you do 2 and 1, I'm very convinced that this is 3. So doing 1 and 1, it doesn't solve the problem, correct? 1 and 1 doesn't solve the problem. 2 and 2, does it solve the problem? It does not.
No.
3 and 3, does it solve the problem? It
Yeah.
does. Finally, you figure. So my suggestion is very simple. Do this first and then do that. Instead of the way you do it, it's just much faster sometime in exam. Okay?
Yeah.
Now that you know it's 1, 3, 2, 3, feel free to memorize if you want to. I will never recommend that. But if you have the capacity, please do. However, learn from me how to balance. That's the more important. Okay, now going back to the question. So the most important reaction is what I will remember first. I feel that this is the most important thing. If you understand, feel free to do so. Now, the whole question is how to make CO. That's what reaction 1 and 2 is for. C plus O2. Why? Because this is my raw material. This is my raw material from air. And this is also my raw material. I have 3 raw material. Make sense?
Mhm.
CO2. CO2 plus C, 2CO. There you go. That's my CO. I'm trying to make CO from the first and second reaction. Do they look like they make sense?
Yeah.
All right, so reaction 1, 2, 3, and then the last 4. 4 and 5. 4 and 5 is the way to deal with the impurity. You just need to know that there's only one impurity they are tested. What is the impurity that they are tested? They're testing, sorry. Is the fact that iron ore. Yes, go ahead. Yes, go ahead.
Nothing.
You're saying, come on, you're saying.
Nothing.
Sorry, I cannot hear you. You're saying?
Like, is there only one or is there multiple?
I don't get what you're saying. Tell me again. Sorry, explain that again.
Like, is there only one or can there be multiple?
Of course, in reality, there are many impurities. But in O-level syllabus, they just care about one, the major impurity, and they just care about how to deal with that one. That's what reaction 4 and 5 is like, how to deal with that one particular impurity. So let's memorize that one impurity. Do you know what that is?
Alpha.
It's not the impurity in the iron. It's the impurity in the iron ore. The iron ore, when you mine, is mixed with something. What is that?
Oxygen.
Nope. There you go. That is the impurity they are concerned with. Sand or dirt. Again, let me show you. You see picture, right? You see picture, right?
Yeah.
I'm going to show you iron ore first, just to show you what it looks like. I have one in my home, but I cannot show it to you, right? So the hematite one probably looks like this one, the one on the right, this one. Okay, this one. Now, why do I say they are sand? Technically speaking, you don't have to imagine the sand inside the ore. You just have to imagine that, this thing. Look at that. That is the iron ore from the ground. That's how you mine iron ore, right? It's mixed with dirt. O-level syllabus simplify for you. The dirt, just pretend that the dirt is sand. Sand is SiO2. That makes sense or not?
Yes.
Okay, so memorize the fact that they only care about sand. I know that dirt is not sand. The syllabus don't seem to care, so for now, we don't care. Now, it will exist as reaction 5, no? Reaction 5. Now, I'll tell you something about acid and base. Now, SiO2 is a acidic oxide. Am I correct? I'm so sorry. Why am I using this? It's an acidic oxide. Am I correct?
Yes.
So acidic oxide plus, surprise, surprise, right? Plus, surprise, surprise. Sorry, acidic oxide. There you go. It's acidic oxide. Should be no surprise at all that you are going to add a basic oxide. Why? Because acid and base reacts. Make sense? The basic oxide is CaO. Why? I'll tell you later. And this becomes simply CaSiO3. Don't even need to memorize. This is your slag. Okay, which is going to be liquid and it's going to be separate. I'm giving you some understanding about reaction 5, the second most important reaction. Reaction 3 is the first one. Reaction 5 is the second one. The dirt, acidic oxide, plus basic oxide becomes slag. Whatever slag is going to be liquid and it's going to be separated from the Fe liquid. Okay, am I making any sense?
Yeah.
So why CaO? Now I'm trying to explain it from, again, a very practical point of view. Like, for example, why use coal? Because coal is very cheap. Why use oxygen? Because oxygen comes from the air. Why use CaO? Because CaO is dirt cheap. What do I mean? Just take something dirt cheap called CaCO3. Like, this is dirt cheap, like super cheap. And then you heat it, which is cheap in a blast furnace, is already hot. You heat it, it becomes CaO. Ta-da! There you go. Plus CO2, which is again a waste. Who cares about the environment? Okay, not that we don't care, but we need iron lah. So, CO2 will be the waste. Again, why CaO? Because the CaCO3 is dirt cheap, like super cheap. This is your limestone. I hope I've explained about reaction 1, 2, 3, 4, 5 quite easily, hopefully. I mean, look at reaction 1, 2, 4, 5. There's hardly any balancing it. There's hardly. Just reaction 3 needs some balancing. So now, with that in mind, memorize them 1 day or 2 days before exam. If you have trouble memorizing, please tell me. If my student don't tell me that they have problem memorizing, I do assume that they can. If they have problem, then I will help them to memorize. There's a lot of things we can do to help them. Okay, Caston?
Yeah.
Now, look at the options. Limestone use a catalyst? Wrong. Okay? Yeah, limestone is not a catalyst. It's
Then
more a
why-
raw material.
Then why is it used?
Oh, it is used. It is used here. Here's limestone. What is it used for? To get CaO. What is used for CaO? To bond with the impurity and, well, make it a slag.
But technically it can be any basic oxide.
Yeah, technically. You want to use any fancy Na2O or MgO can. It's just not as cheap. So the memorizing is more of what's the cheapest, most practical thing. But anything is fine. You can use NaOH if you want to. I hope that makes some sense. Wait, technically, no, NaOH cannot. You will evaporate in the, I'm sorry, but there's another practical consideration. You cannot use any basic oxide which will evaporate in the 1500 degrees Celsius. So happens CaO does not evaporate there. So I guess that's good luck. That's kind of another practical consideration. That won't evaporate. Yeah, they won't be boiling. I think NaOH will boil at that point. So that's the long story of why they ask you to memorize these 5 things. It's very practical in there. Okay, limestone is not a catalyst in this case. Slag is formed due to a reaction between acidic and basic oxide. Now you know it is correct. Okay.
Mm.
The main impurity in the iron form is slag. No, this is totally wrong. Do you know why D is wrong?
It's the sand.
Also wrong, also. Okay, one more time. The sand is the impurity mixed with the Fe2O3. If you don't remove the sand, the SiO2 will be mixed with the Fe, kind of melted. But now that you remove it by making it into slag, slag and Fe is removed, as it is separate. So the impurity in the Fe is no longer the sand, nor is it the slag. If the slag does not separate itself from Fe, we don't bother making the slag. Then it doesn't make a lot of sense. Then might as well just stick with SiO2 lah. But the reason why we put SiO2 with CaO, because the resulting slag do separate itself from Fe nicely. Very nice. So far so good. Do you understand?
Yeah.
The main impurity is carbon mixed into the Fe. It is not shown in the reaction. It is more like a knowledge, a chemistry knowledge. Can you accept that?
Yeah.
So these are hematite containing manganese is reduced. The problem is the iron 2 is the problem. So it should be iron 3. Okay, tell me, hematite, is it reduced or not? Is that correct? Oh, there was a dispute.
Yes.
Yes, this is 0 oxidation state and this is +3 oxidation state. So the reduced part is correct. The iron 2 is the problem. Do you understand?
Yeah.
Turns out this MCQ tests almost all of your blast furnace. Basically, it is a very dense question. Okay, good that you asked. Hope that you learned quite a lot of things.
What is it?
Okay, I understand this reaction. What is your question?
What's the point of the hydrogen?
Okay, Let me explain the main reason of the reaction. If you don't understand the reaction, you cannot understand the hydrogen. Okay. Now, I'm going to ask you to repeat reactivity series. I teach you to do it this way, right? C, H, and then 3 dots, and then 3 dots. Remember? Okay. So tell me where copper is.
This one.
Where is copper in the reactor? Where? Which one? Show me. You just show me the Jamboard.
This one.
Which one? I need to see. Okay, yeah. So here's your copper. We don't care about the rest now. Why? Because there's a copper 2 oxide here, and then there's hydrogen here. So we care about this guy. This one is actually the hydrogen, and this one is the copper metal, just saying. So the second thing I teach you is that there is a mirror image here lah. And this is the H. So far so good?
Yeah.
This will be your copper 2 oxide load. And then this will be whatever the hydrogen is lah. Now, look at it for a while. This is burning and everything. This is copper oxide. This is hydrogen. To me, it is very clear that this is hydrogen jumping down to force copper to jump up. They call it displacement lah. Do you understand that this is basically displacement reaction?
Yeah.
All right. Now, since you understand that, why do we flood hydrogen? I mean, in fact, why is it dry in the first place? Dry means there is no H2O, right? Let me answer the dry question first, even though the question never asks, because the reason will be the same one. There is no oxygen. The problem is the oxygen. The whole point of this reaction is to make copper 2 oxide into copper. Water, because it contains hydrogen, will quickly will make some of them back into CO2 with the help of H2. Okay, so no hydrogen and no water, please. No COO in the product. So far, so good?
Yeah.
Now, I hope that makes sense. What is the main reason why the hydrogen is kept flowing? If you don't, what will happen?
This one won't get displaced.
Which one? Sorry, which one? Sorry.
Not the copper doesn't get displaced.
Oh no, I see. No, I'm sorry. I see what, no, I see what you mean. I see what you mean. No. Let me explain. The burner is then turned off. In a sense, the reaction stops when you don't have enough heat. Burner is turned off, reaction very soon will stop. You need a rather high heat. Even though displacement is automatic, turns out you still need a certain amount of heat. So when the burner is turned off, the reaction stops quickly. But even though the reaction stops quickly, hydrogen is kept flowing until the tube is cold. Why do you want the tube? Why do you wait until the tube is cold? It's a very practical consideration. What is it? In lab, you will wait for the tube to get cold. Why? In lab.
Hydrogen is flammable.
Wait, how come your mic today is very bad? I cannot hear you very well. Wait. Yeah, let me do something. Sorry about that. Now, would you please explain again? This is the lab. Why would you want to wait for the tube to get cold? Opinion is fine, Keston. Yes, go ahead.
Is hydrogen flammable?
Well, if hydrogen is flammable, which you're right, see, the hydrogen is burning there. So you're totally correct. Hydrogen is flammable. Then you should stop the hydrogen flow. not keep it flowing. I agree with you, hydrogen is dangerous. In lab also dangerous, very dangerous in fact. Why keep this dangerous thing flowing? If the hydrogen is the problem, turn it off. Correct or not?
Yeah.
So this question really, begs the question, why keep the dangerous thing flowing? Yeah, and you still haven't answered my question. So why do we wait for the tube to be cold, then you turn off the hydrogen? What's the point?
The
It
heat.
better be worth the danger. The heat, yes. If it is a lab, you gotta wait until the tube is cold, then you can handle it lah. Correct or not?
Yeah.
So from a practical point of view, you have to wait. But when you wait, you don't turn off the hydrogen, something bad or something that you not desire will happen. So that is the context of this question. And the question is rather deep or rather practical. If you let the heat cool down, the copper oxide, the copper that is formed is still hot, correct? It is still hot. But no hydrogen. So what happened to the copper, which is still hot, waiting to be cold? Okay, hydrogen kept flowing, lessen the risk of explosion in the hot tube, definitely wrong. More hydrogen, more risk. So A is wrong. Make certain reaction is complete, wrong. Heat off, reaction off. Correct?
Yeah.
Left with C and D. Come on.
E.
I would rather choose C. I don't know whether I'm right or wrong, by the way, but I would really rather choose C.
Why would it prevent the copper?
If you blanket the copper with hydrogen, then no oxygen will touch them. No oxygen will enter the tube, because you have been flowing. This dry hydrogen is implied to be pure, dry pure hydrogen, no H2O. Then obviously no oxygen involved. So when you keep the hydrogen flowing, you're preventing air from going into the tube and convert some of the copper into copper oxide. Very easy to happen when the CU is still hot. Very easy. You wait it to cool down, much less, much slower. Would that make some sense?
Yeah.
The flow of the hydrogen as an added advantage helps it cool down faster also. But you cannot blow air. Again, if you blow air, the problem happens. You go back to CO. Okay.
Yeah.
Not an easy question. Yes, a lot of layers, but nobody say SBQ is easy. Nobody say. Right. Next question.
For the question just now, what does mild steel mean?
Right. So go back to the question. Right. Mild steel is soft steel. When they say mild, they actually mean soft versus hard, right? So high carbon steel is hard. Why you should know that? Because you learn from chemistry alloying. You put in more carbon to alloy with the steel becomes hard. So it is implied pure steel is rather soft. So mild steel is like maybe almost pure steel, almost pure Fe, which is actually kind of not so hard, if that makes sense.
Yeah.
Now, you don't want that for a knife. You don't want that. Okay. Then the knife becomes dull quickly because it is soft. Not good at all when you're trying to cut flesh. You want a very nice, clean cut. Really not good. Really. Good question.
What is that?
Oh, sorry. Okay, so Caston, this is no longer metal. This is identification of metal ion or cations, lah, right? Cations.
Yeah.
So this is like QA, lo, qualitative analysis. We never talked about this before. May I know, do you even remember the reaction so far? Most people forget, man.
Yeah.
Sorry. Barely, is it? Your mic is very bad today.
Yeah. Yes.
Okay, barely. Then, but you need that. If you have it, you got it. So for now, I'll just show you the table. It might be different from yours, but it will work. Okay, it will be very clear what the answer C1 is. Again, I'm saying it's just based on that memorization. Okay, I'll just show you. Again, that one is a very intensive memorization. You have trouble, you gotta tell me, not near exam, okay? Tell me lah. But right now, if you forget, nobody's complaining. It's silly to remember that now. I'm just taking this from the other students' memorization work. That student has a problem with memorizing, so I cannot discuss how to memorize with him very quickly. Okay, this is a lot of scratches, so too bad, yeah. Just take it for you. So if you understand, this will be Pb2 plus, not Pb metal. This will be zinc 2 plus, and this will be aluminium 3 plus. Do you understand that?
Yeah.
So happens ZAP is in the, ZAPC, right? Is in the table which is you're supposed to memorize. Lah. The NaOH is the NH4OH is here equals ammonia. Do you understand?
Yeah.
The problem here you learn a problem, they intentionally put it in the syllabus. Aluminium 3 plus and Pb2 plus cannot be differentiated. Their test result is exactly the same. Do you remember that? That is an intentional problem.
Yeah.
But zinc 2 plus has a slight difference here. Lo. So why equation can be used only one? So they are because it can only identify zinc 2 plus. The reasoning is because the test result of aluminium 3 plus and Pb2 plus are exactly the same. Okay?
Yeah.
That's just the revision. Right? So this is nothing complicated at all, not very deep, lah, right? As long as you understand the issues, you can answer. This can understand between the two other ions. So this is getting deeper, no? So this is only zinc 2 plus. Now, how are you supposed to differentiate between Pb2 plus and Al3 plus, lah? Right? Now, it won't be in. It's not here, lah. It's not here. The answer is not found here. Do you have any other idea?
Bonding.
What do you mean?
Not sure.
Okay, go for solubility, lo. One example. This is only one example, okay? Go for solubility, which means you gotta remember your solubility table, lah. You remember them.
Yeah.
Okay, so tell me, Pb2 plus is a great offender of solubility. It is very easy to make it insoluble. Tell me an anion which will make Pb2 plus insoluble. There's a
Chlorine.
lot of them. Wait, yeah, yeah. Add anything with Cl minus lah. This will become PbCl2, which is no longer soluble, right? This one, AlCl3, definitely soluble. Well, there you go. You differentiated already. SO4 was fine also. Okay, that's it. Not so difficult. Okay? That's just the easiest way to differentiate them. If you understand how the question thinks and how they ask you, then you are quite good at QA lah. This is like almost the deepest end they can ask already. Keston, I was assuming that you don't need to take notes for yourself, but you can absorb this and understand this. Is this correct?
Which one?
All the questions that you ask are medium or deep question. Some people are very comfortable with understanding, no need to write notes lah. I'm just going to confirm that you don't need to write notes for yourself. You will remember this for exam.
Like if I forget, I can just refer back.
Yeah, the problem is Jamboard is very messy. My writing is very messy, and you may not understand this next time. Are you sure you will understand this next time?
Probably.
That's fine. Let's test lah. Let's see what happens. Okay.
Question on the form.
Oh. Oil and paint. So this is a guess, yeah? This looks like the last part of the question. Am I correct?
Yeah.
Correct. I don't think this is part of the syllabus. I think this you gotta use some sort of thinking, combining your existing knowledge lah. So anyway, I don't have the answer key, so I'm just gonna have to give you an answer and then justify it lah. That is the style here, and we never rely on answer key lah. You can compare it if you want to. Now, they say underground pipes lah. Okay, oil and paint. So I'm guessing that oil and paint are used for protecting from corrosion. Is this correct?
Yeah,
The context of the question. Okay, so why don't we put oil and paint to protect underground pipes, which is true. They do not do that. Practically speaking, they don't at all. Okay, I think oil is very clear. If you coat your pipe with oil, put it underground, what will happen to the oil? Or rather, what will happen to the the things in contact with oil?
Become like harmful.
Yeah, you'll pollute lah. The oil will pollute, and anyway, it doesn't stay long. Anyway, okay, there's a lot of things underground that will just wash away the oil, and that truly becomes a pollutant. So it doesn't stick, and it's a pollutant. So oil is gone. Now paint. Paint does stick, I suppose, but the problem is you bury it underground. So paint will almost immediately scratch. When the paint scratch, you know what happened?
No.
You will immediately start to rust very quickly there.
No.
Did they tell you that? If a paint is scratched, the problem with scratching paint is the point of scratch will rust very fast. Almost like, I mean, not as fast as the iron coated with zinc. If you coat iron with zinc, the problem is when you scratch the zinc, the iron there rusts very fast because of zinc. Wait, am I making any sense here?
What's the difference between scratching off paint and not putting any paint?
Oh, no. You gotta protect it somewhere else. This question doesn't mean that you shouldn't protect with nothing. No, you should protect with something else other than oil and paint. If you don't protect with paint and then you don't scratch, everywhere will rust slowly. Okay, that's ideally lah. Everywhere will rust slowly. Doesn't seem that bad. In reality, certain part will kena focus one. Certain parts in contact with more moisture will rust more than the other part. So in the end, you will still have bad rust here and there. My point is, paint easily scratches. That's my point. You're burying the pipe. It's a very rough work. If you get what I mean.
Yeah.
Paint is not anti-scratch. So it's a little bit, no, it's not really problematic. The pipe is so long, you just need one part to scratch and then rust quickly and then leak already. You understand what I'm saying? Paint is not good enough. That's the problem.
Yeah.
You gotta use some other method, but thankfully, they don't ask you. Because, frankly speaking, it is extremely difficult to protect metal pipes underground. Believe it or not, they prefer to use concrete pipes, which don't rust, kind of, or plastic pipes. They almost never use metal pipes underground because it is impossible to protect cheaply. Impossible. How do I know that? That's practical knowledge. And I'm thankful that they don't ask you. It's very difficult to answer. Okay. This part is supposed to be quite difficult. You gotta think more. For 1 mark, it's not worth it in exam. For learning, definitely.
I put another one.
Oh, next page. Good job reminding me. Right, now vanadium is not part of the syllabus. So when they test you vanadium, they are intentionally giving you something out of the syllabus. Do you understand what I'm saying?
Yeah.
What is the question maker's responsibility when they give you something out of syllabus? I mean,
They need to give you all the information.
excellent. Do you understand the 3 sentences, therefore? That's your responsibility.
Yeah.
Now, let me check. Let me check. They give you this, they're being very sneaky, okay? Even though they know they're supposed to give you, but they're being very sneaky about it. They're sneaky in the sense that they at least tell you, go, hello, bro, sister, oxidation state is important. But they again become sneaky and then they'll tell you, oh, what's the oxidation state of V2 plus? Just checking.
+2.
Good. What is the oxidation state of 3 plus? +3. What is the oxidation of VO2 plus?
-+3. Wait.
No. Wait, plus. No, you're correct. Plus. No, I'm sorry. You're wrong. It's not +3.
+5.
It is plus. Good. +5. You know why?
Yeah.
Clear, yeah? VO2 plus.
+2.
+4. VO2 plus. +4. Makes sense or not?
Yeah.
Now, based on my experience, granted, I know they will hide certain things. Sneaky. They give you, but they hide you. But they will also tell you what to do. And so without reading the option, I don't care about the option. I never care about the option until I figured out the oxidation state. I believe, based on experience, they will be very important. Now, have you thought about that before? If you have not, try figuring out whether A is correct first or not. You might need it. Oh, you don't. You just blue, green, and violet. Okay, never mind. You don't need it. So anyway, is A correct or not?
No.
It's +2 to +3, which is wrong. Okay, too bad. Now, Question mark. Vanadium comes. Oh no, this is like totally wrong. Okay. I'm sorry. Did I tell you catalyst usually uses transition metal? Catalysts are usually transition metals, exactly because they have many oxidation states. They don't explain this too much even in JC lah. So for O level, it is enough to simply almost like memorize this because you don't even know how catalyst works. In JC, they explore that a bit more. So you memorize, oh, catalysts are usually transition metals because transition metal has many types of oxidation state. You can switch in between, but you never truly understand why that is important. But C is wrong because of that. Can you accept this?
Yeah.
Nasty question. Now, as for vanadium has a low melting point. Probably being an ionic compound, that's not a good bet. I think D, I won't bet on D. I hope that makes sense.
Mm.
I have no idea whether vanadium has a high density. I don't even know what is the density of aluminium. I don't even know. But A is wrong, C is wrong, D is wrong. I mean, whatever lah, I just take B as my bet. I do not know whether B is correct or not. But I'll take it. That's my thinking exam. Okay.
Mm.
Does it help? Do you want to Google the density of vanadium compared to steel, for example? Do you want to do that?
Okay.
Okay, let's do that. Remember though, in exam, you don't have that information and you're supposed to answer the question in another roundabout way, like how I do it. This is wrong, this wrong, this wrong, for example. Right? That's why elimination is important. Now, vanadium, iron, that's it. Check it out. I have no idea what this is. Oh, I don't want image. Density of all metals, right? Let's do that. Steel is 7.85, right? Okay, around there. So where is vanadium, right? Vanadium is there. 6.16. I don't know whether that's high or not, but I guess it's not so bad, I guess. Does that make you feel better?
Yeah.
There are others which are much higher. Let me show you aluminium. Where's aluminium? Make you happy. Where's aluminium? There, aluminium is 2.7. What do you think? Does that make you feel happy?
Yeah.
All right. Again, I learn not to care about what I don't know. I learn not to care. I learn to care about what I either know or what I can figure out in exam. That's the secret to doing A1. People getting B3 or currently getting B3 A2 probably care too much about what they don't know, probably. Put it another way, even I don't know certain things, right? I cannot know everything, but I can figure out many other things. Perhaps that is what I want you to learn. Okay, metal, right? Okay, so again, very fancy, a lot of thinking kind of question, See, your questions are good It's difficult that way. Now, tell me, what is your question? Is it everything? Is it something?
How do you know if it's 4? If number 4 is correct?
All right. So tell me 1, 2, 3 first. What do you think about 1, 2, and 3?
One is wrong.
Okay. Then 2.
Wait, everything can be electrolysis, right?
You are not wrong. Yeah, you're not wrong.
2 is correct.
3. It depends on, is it?
2 is correct.
And then this one is the question, right? Okay. So I think 4 is wrong because it doesn't seem to no other chloride of X exists. So he's saying that only X plus exists, basically. The reason why they say no other chloride exists because outside syllabus, this is very controversial. You're supposed to know that Cl can be -1, but Cl can also be +1, and then +3, and then +5, and so on and so forth. Right, that this is outside syllabus, and then yet sometimes they seem to want you to know that. It's very controversial. So I'm just explaining to you, I'm not debating the syllabus. Since he say no other chloride exists, that means only Cl minus, which means only X plus, which means this is wrong, if that makes any sense.
But then what if X is like 3 plus?
Again, no other chloride of X exists. So if X is 3 plus, you will just use Cl minus, which is XCl3, which is another chloride.
Mm.
Make sense?
Yeah.
They are telling you something and they are hiding it in a very smart way. Sneaky, sneaky. You gotta interpret what they're saying. Sneaky, sneaky. Okay. Now, with that, can you answer the question?
C.
Yeah, lah. If 1 is wrong, then 2 and 3 lah. If 1 is correct, then 8. Okay, you think about it.
Who wants it?
Okay. Okay, sure thing. What is your question?
All of it.
So an alloy is simply a mixture of metal with something else. It's not always metal and metal, okay? For example, Fe with carbon is alloy lah. So anything lah. Okay, bronze. So this is your steel, right? Then bronze is an alloy of, keeping it simple, copper and zinc. Okay, so metal, metal or metal, non-metal, whatever. Metal, non-metal, this one metal. So now they are good conductors of electricity as mobile ions. I mean, they have majority metal, correct? No? Okay. I'm so sorry. The mobile ion is a problem. I'm so sorry. Mobile ion is wrong. Should be mobile electron or free electron or delocalized electron. So this is wrong. Okay. Perform a chemical reaction between metals is also wrong. They are just a mixture. They are not a compound. Sure, not compound. Am I making any sense?
Yeah.
The represent biological formula? No, because mixture, not compound. Same thing. Okay.
What does molecular formula mean?
Okay, last thing first lah. This is wrong. This is correct. So this is correct, right? Now, molecular formula simply means the composition stays. The composition is fixed. That's what molecular formula means. You can fix it. Fe2O3 is always 2, is always 3. An alloy doesn't work that way. It's a mixture, not a compound. Am I making any sense?
Yeah.
Sorry, yes or no? Sorry?
Yes.
Okay. That's it. That is considered basic knowledge. They just use very fancy words, very fancy concept. But please understand it. They are basic, so you should. The question itself are constructed in a challenging way, right? But that's your school, SST.
The sea of electron is just big and small ions, right?
No, CF electron are literally just electron.
Right.
Sorry, why did you say that? Sorry.
Like, how do you draw it out? It's just the big and small circles.
No, you're correct. You gotta draw the positive ions that representing the metal ion. That's what. And then you simply pepper electrons like that. That's your metal bond, metallic bond, right? Metallic bond will involve CO. Yeah. Tell me if you know. Yeah. Okay, what is your question?
What's the point of the wool?
No. It's very similar. The wool is very so. I'll draw the wool for you. Like that. Something like that. Correct.
Yeah.
So this is very similar in function to powdering law, which is to say to increase the surface area of them. It's not a block. It's a wool, means it's a stringy stuff, which means surface area or exposure. Easier reaction, faster reaction. Make sense?
This reaction with what?
Don't know yet, but the mineral wool saturated with water. Maybe water is the reaction. I don't know. Maybe. Or it is simply steam passes over a heating solid. So not sure about this. So maybe it's the mineral wool reacting. Maybe it's the steam passing over a heated solid. If I follow the question, strictly speaking, it should just be steam reacting with solid P, and the mineral wool is there just for heating purposes. Because it's very difficult to heat water, it's probably easier to use mineral wool. I am just guessing at this point. So far, so good?
Yeah.
Now, since you only asked for P and Q, then I will just don't bother about the mineral wool at all at first, and I'm just gonna pretend that it's just steam, which is H2O. So I don't bother about mineral wool for now. If I get an answer, then I'm happier. Okay, so far so good, yeah?
Yeah.
Now, unfortunately for Q, I want to eliminate oxygen. I cannot. Oxygen will still be lighter than air. Correct?
Yeah.
Unfortunately lah. So I wish I could, but I couldn't. So I have to think more lah. Okay. I don't know. P plus H2O. To help me think, I will just write like this lah, right? So this is either hydrogen or oxygen. And then you know what? I'm going to make a guess. This is the reactivity series. Carbon, hydrogen, H plus. Why do I add H plus? Because this is my H, correct?
Yeah.
The oxygen is also there. It's just that it is not in the positive reactivity series, but it is in the negative reactivity series. It does include oxygen. How do I memorize it? FCl2, Br2I2, and then oxygen kind of goes in here. That's how I memorize it. So then everything else here is, I minus, Br minus, Cl minus, this is F minus, and usually this is not O2 minus, this is the OH minus from the electrolysis, right? But the explanation given, it can also be given. Let's be open. Right? Yeah, no explanation given. It's given in JC. So for now, let's just pretend that the O can be O2 minus or OH minus. They are O2 minus, right? That's it. So now, I'm not sure what I'm supposed to think here. If this is oxygen, then oxygen clearly experience some sort of jump here. Clearly, degrees of oxygen. Correct?
Yeah.
If it is hydrogen, then hydrogen experiences a jump. Now, I'll tell you something about making oxygen. Nobody makes oxygen. That's probably the easiest thing. You never see a reaction that makes oxygen. There's only one. Tell me what it is. There's only one.
Like photosynthesis.
Yeah. The reason is, look at the reactivity series of the negative one. The jump is very high. The jump is higher than Cl minus to Cl2. Making Cl minus to Cl2 is already considered difficult because it is very reactive. Making oxygen is more reactive than making Cl2. If you try to make something so reactive like oxygen is considered very reactive, it is very hard. So by experience, and this is chemistry knowledge, by experience plus chemistry knowledge, I am almost certain I will cancel oxygen already, just because of that. By experience, there is almost no reaction that makes oxygen. Making oxygen is considered a miracle of sort. Do you understand what I'm saying?
Yeah.
Obviously, though, they don't teach this. Example, in electrolysis, you can make oxygen. Well, electrolysis is the special reaction to force very difficult reaction. And this is not electrolysis. So again, photosynthesis to make oxygen, electrolysis to make oxygen. These are neither photosynthesis nor electrolysis. I am just going to save myself time in exam and cancel oxygen. Okay. Now, I'm going to put copper. Copper is here. And then I'm going to put zinc is here. Looks like both are definitely possible in terms of making hydrogen. Okay. I'm going to choose copper because this is only heat. I'm going to choose copper. Wait a minute. Wait a minute. Wait a minute. Zinc also can. So which one do I choose? Okay, let's agree first. If copper can, zinc definitely even easier. Zinc is more reactive than copper. So certainly P can be copper and also can be zinc, if that makes any sense. I am so sorry. I'm so sorry. What am I talking about? I'm already sleepy, is it? I'm already very sleepy. I'm so sorry. I'm already very sleepy. Copper cannot. What am I talking about? Oh my goodness. I'm so sorry. Copper cannot. Zinc. I'm so sorry. You understand why copper cannot?
Also appears by itself.
I'm so sorry. Your mic is very bad. Try again.
it's not very reactive.
They'll ask you fancy words. I explain it in a very simple way. The jump down is smaller than the jump up. Cannot happen automatically. One. The jump down provides the energy, man. The jump up requires energy. If your jump down is smaller than jump up, then it will not, so to speak, happen. I know there's heating involved, but oh my goodness, they don't teach this in the O level. So just remember that if you just heating alone, jump down cannot be smaller than jump up. I'm using my own terms for now. Am I making any sense?
Yeah.
But the zinc one, the jump down is higher, so it works, that kind of thing. Okay, not the easiest question, but very, very good.
Next page.
Oh, sorry. Okay. Which one?
Mm, what was,
Sorry, which one? 32 or 33?
33.
33. Oh, okay, right. So, I don't know. I don't memorize the melting part, but I concentrate on the decompose one. That one, tendency people should memorize lah. So anything above calcium carbonate does not decompose lah. So again, the reactivity series memorization. Tell me if this doesn't make sense, okay? So you will hit this group 1, group 2, group 3, and then in group 2, you will have magnesium here and carbonate here, right? Okay, here decompose by heat, here not. So does not decompose is kind of easy. This one. I don't know about the melting part lah. I don't memorize the melting point, I guess. That I don't think that's worth it. Okay, but I do memorize the does not decompose. Because it's a very easy boundary. Memorizing melting point, there's a lot of numbers. He doesn't even tell us what kind of temperature he's doing. I don't think the question is done honestly lah. I think the question simply wants us to focus on the does not decompose. I hope that makes some sense.
Yeah.
In fact, I think most carbonates melt on heating. I think all of this carbonate here. Oh, I'm sorry. Most of them decompose. So what they mean is if you melt, you don't decompose. I'm so sorry. Now I understand. If you decompose, you don't melt. Okay, I think I get it. Sorry about that.
What about 32?
What about what? Sorry?
32.
52, right? I mean, I told you about B just now. B is decomposition. Sorry, did I tell you?
Yeah.
So this one, the extracting iron, no. Ethanol from ethene, no. You learned that. That's actually dehydration. This one also no, right? That's a Haber process.
How do you explain
Yeah.
more decomposition?
Going back to page what is it? What is that? Okay, so the 5 reaction of blast furnace lah, right? The dirt chip calcium carbonate is used to obtain CaO. This is decomposition by heat. There you go. Meaning to say, you ought to recognize reaction 4 as decomposition. They never, maybe they say it clearly, maybe they don't, but this is clearly decomposition of carbon.
It's
For
not
the
thermal decomposition.
that thermal, in O level, there is no other decomposition. When they say decomposition, they mean decomposition by heating stuff like thermal decomposition, all means the same thing. You heat that stuff changes, I suppose, without actually reacting. This is not reaction by oxygen, reaction with the air. This is just them changing by themselves. That's decomposition. Am I making any sense?
Yeah.
Right.
I have like no more questions.
Good. Your questions are great. Now, is this holiday homework done then for you?
No,
Really? You mean for, I mean for chemistry. I mean for chemistry.
I didn't finish it.
Do you think you will be able to finish it?
Yeah.
Okay, cool. Good. When I see you next week, I think we can go to exam questions more and more. Okay. I hope you're quite satisfied today, and I will see you next week.